Math 3, Unit 2, Section C. So today we're going to talk about solving and graphing absolute value inequalities. So yesterday we talked about equations. Today we talk about inequalities. So you'll look, if you see here, the absolute value of x is less than b. Less than means that it's an and so when you write this, it'd be x is less than b, and x is greater than negative b. So do you guys remember how whenever you multiply or divide by a negative with an inequality, what do? So if I had something like negative 3x is greater than 21, and we're trying to solve for x, what would I do to both sides? Divide by negative 3. And then do you guys remember what happens when you divide by a negative with an inequality? You flip the inequality. So you end up getting x is less than negative 7. So it's the same idea here. So when you have the positive, it's the same. But when you write the negative for the absolute value, it flips the sign. Okay, do you guys see that? So that happens on all of these. And basically these are the same. It's just that if you have the equal to sign, you keep the equal to. Another thing, and this is kind of how I remember it, if you notice when it says and, it's going to be where the graphs overlap. So when you have the absolute value here, you end up with two different equations, correct? And so when it's a less than problem, you end up with an and, meaning the answer is where the two graphs overlap. How I kind of remember this is I say that as less than, kind of reminding me that when you see the less than sign, it's going to end up being an and statement, so the answer is where the two graphs overlap. On this one, these are greater than signs, so I say that kind of like great or, reminding myself that when you have an or graph, and if you can see this, the ors go usually in opposite directions. And so the ors don't have to overlap. Your answer is like one or the other. So another note I kind of wanted you to put here on the side is to remind yourself that if you multiply or divide by a negative number, you flip the inequality sign. Also, when you have the and problems, your statement can be rewritten. So see how you have the overlapping graph right here? This answer could actually be written as negative b is less than x is less than b. So if you go from your smallest number to your greatest number, you have the two less than signs there with the x in the middle. So that's like basically telling your answers from here to here, right? And so same thing for this one, except for you would write this as negative b is less than or equal to x is less than or equal to b. All right, and so that's kind of what was talked about here as well. Okay, special cases. When b is less than 0, the absolute value of x is less than 0, and the absolute value of x is less than or equal to b have no solution. So let's think about this. What does it mean if b is less than 0? What kind of numbers are less than 0? Okay, negatives. So the way I think about this is if I were to take the absolute value of something, the absolute value will always give me what type of number? Positive. So is a positive number less than a negative number? Is that true or false? False. A positive is not ever going to be less than a negative, right? And so therefore it is no solution. Okay? But if you have a negative number here, and this time it has greater than in there, so if we were to take the absolute value of a number, we'd get a positive number, and as a positive number greater than a negative number, that one is true. And so that's one would be all real numbers. And we kind of do that little R thing with that, right? And so anytime you get a negative answer with inequalities, it's not always going to be no solution. So it's either going to be no solution or all solutions. Does that kind of make sense? Do you guys see the difference between the two signs? Okay. So these steps are similar to what we did yesterday. And so let's go ahead and go through some examples. So again, you're going to do part where we're graphing it and then part where we're doing it algebraically, and we should end up with the same answers, right? So whether we're graphing or solving it algebraically, the answers should end up being the same. So if we're going to graph f of x, what would I do first? What is my vertex there? 0, -2 is correct. Okay, because nothing's with the absolute value, and then we have -2 at the end. So 0 down 2, we make our point, and what is my a value here? It's 1, right? And so we're going to go up 1, right 1. Since I know, and in fact, I don't know if you want to do this, but if I were to mark g of x equals 3, so that means we're going to go up to 3 and make our line, right? So that it's easier for me to see, I might end up doing my slope all the way up till I get to that line. I'm just going to mark that as g of x, so that I know the exact point that it intersects. And so then we can draw our lines here for our absolute value. Okay. So what would be the answers for this problem originally? Very good, -5 and 5. Okay, so it says highlight the portion of g of x where f of x is greater than g of x. You could also think of that as well as like g of x is less than f of x. Okay, because so we're going to be highlighting the g of x graph. So my blue line is my g of x. So looking at that graph, can you tell where g of x is less than f of x? Where?
What does that mean?
So do you see like right here, so this graph is my f of x. Okay. So right here, do you see how f of x is actually less than g of x? So because it's below the line. So here's g of x, here f of x is below. So where is f of x above?
It's less than -5.
Good. So if you look right here, this is where you would highlight. So going from here to the left and here to the right, that is where g of x ends up being less than f of x. Or f of x is greater than g of x. But they're asking me to highlight on the g of x. So it makes more sense to me to think about it in terms of g of x. Where is that graph less than f of x? Okay, so let's solve it algebraically so we can see what happens there. So it says that we're going to write this as f of x is greater than g of x. So if we write our equation, we have the absolute value of x minus 2 is greater than 3. Okay, and then what would we do to solve this? Good. Add 2 to both sides. And so we have the absolute value of x is greater than 5. And then now that we have isolated the absolute value, we would set up our two equations, correct? And so we'd end up with x is greater than 5. And then what would be the other equation?
X is greater
close. What do we do when we have the negative equation?
Oh,
Good, so it's gonna be x is
less.
less than negative 5, and there's nothing left to solve there. And so, do you see here how it's highlighted where it's greater than 5? And here it's highlighted where it's less than negative 5? So it is the same answer, correct? All right, and then for this answer up here, they're wanting us to write it in our interval notation. So you know that's where we're using our parentheses and negative infinity and all that kind of stuff. So how would I write these answers?
Just union.
Say that again?
Could you use like the union?
Yes, so we're gonna go negative infinity to
Y, negative 5.
negative 5, and then our union, and then we have,
5 to possibly 8.
good. And then why did I use parentheses?
Because it's like there's a chunk in the middle.
That, and then also, do you see how these don't have the equal sign for our inequalities? And so if they had the equal sign, I'd probably end up using the bracket. Since it doesn't have the equal sign underneath, I'm going to use my parentheses. Okay. All right. Any questions there? And this one, see how it's two separate graphs? They're not overlapping. This is an or, and so in the inequality, it's just x is less than 5x or x is less than negative 5. Okay, and so these two answers.
Don't you mean on the one on the left, don't you mean greater than 5?
Yes, thank you. Okay, so, and these mean the same thing. Okay, are we good? Questions? Okay, does that make sense how you're supposed to highlight and stuff too? Okay, so we're gonna try this next one. All right, so we're gonna start by graphing. So when I'm graphing g of x, what is my vertex?
Negative 4.
Okay, if we can do f of x first. So we're just gonna do a line at negative 3, right? For my f of x equation. And remember, it's a good idea to always label these. And so this right here is f of x. Okay, so now g of x, what is my vertex? Good. And then my a value is? Good. So negative 4, up 0, and then from there we're going to go down 1, right 1, down 1, left 1, and then again I'm going to kind of do all the points until I get the line so I can see exactly where they intersect. Okay, so can you guys see which values the two graphs intersect at? Good, negative 7 and negative 1. So we know when we do it algebraically over here, I should end up with negative 7 and negative 1, right? Okay, so now it's asking me to highlight f of x. Okay, so we're highlighting f of x, where f of x is less than g of x. So where is f of x smaller than g of x? Very good, just like right here in the middle. This is when it is less than g of x, because then past on the other sides, g of x ends up becoming smaller. Correct? Okay. So how would I write that in my interval notation?
Negative, and then the absolute value bars x plus 4.
Oh, okay, yeah, hold on one second. Before that, do you guys, so if we're just talking about this part of the graph, what we're going to write on this line, what should we write?
Negative 7 and negative
Good, and will it have parentheses or brackets? We're going to do brackets. Why am I going to do brackets?
Equal sign. Equal to sign.
Very good. It has that equal to sign with our inequality. Okay. All right, so now we can set up our equation. And so f of x, it has negative 3 is less than or equal to negative absolute value of x plus 4. Now, when we're dealing with inequalities, you always want the x, your variable, to be on the left side. And so we should end up flipping this around. So with inequalities, you can move everything from one side to the other, but if you have the open mouth going to this side, when you end up moving it, you need to keep the open mouth going to it. Okay, so let's go ahead and flip this around. So I'm gonna have negative absolute value of x plus 4. And then, so since it's open going to this, I'm gonna keep it open. So the inequality sign ends up flipping there. Do you guys understand what I'm saying? Yeah? Is anybody confused? A little bit? So do you see how the open mouth part, like the bigger part, open part, is open to this? So when I change this around, I just want to make sure I keep the open part going to that. Okay, is the absolute value by itself? No, so what do I have to do to get it by itself? Good, so we're going to divide by -1 to both sides. We get the absolute value of x plus 4, and then what happens when I divide by a negative number? Flip the sign, so it becomes less than or equal to 3. Okay, and then at this point now we can write our two equations, right? And so we end up with x plus 4 is less than or equal to 3, and then the other one is x plus 4 what? Greater than or equal to -3. So we subtract 4 to both sides. We get x is less than or equal to -1. Here we subtract 4 to both sides, and we get x is greater than or equal to -7. Do you see how this was an and problem? It's less than, so it's an and. So the answer is where the two graphs overlap. We can see on the graph how it's the two graphs overlapping right here. Yes? Okay. So whenever it's an and where it's overlapping, that's when you want to write your answer as like a single statement. And so how could I end up writing this with my inequalities? Remember how I talked about over here at the beginning, how we can, with the ands, when it's overlapping in the middle, how you can write it like this. So you always start with your smallest number to your largest number, and then you have the less than signs with the x in the middle. So what is my smallest number? So it'd be -7 is less than or equal to x is less than or equal to -1. And that's saying that all the numbers between -7 and -1 are a solution to this problem. Questions? No? Okay. So the second part of your homework is just solving these inequalities algebraically. You don't have to graph them. Okay, so and if you write, it says write the solution in interval notation. Interval notation is when you use like your brackets and parentheses and stuff, okay? So once we get our answers, we're gonna write them like that. Is the absolute value by itself on number 3?
Yeah.
Yes, so once we have it at that point, we're gonna write our two equations. So we have 3x minus 9 is less than or equal to 12. And my other equation will be 3x minus 9 is perfect. Okay, so now we're going to solve both of these. On this one, we add 9 to both sides. 3x is less than or equal to 21. Divide by 3, and we get x is less than or equal to 7. Over here, I add 9 to both sides. I have 3x is greater than or equal to, and -12 plus 9 is, and then we divide by 3 to both sides. Then we get x is greater than or equal to -1. Okay, sometimes it's difficult to see what's happening with these graphs. If that is the case, you can always graph them, which will maybe sometimes help you to write your interval notation. So if I were to graph these, I'd have -1 and a 7, right? At -1, it's closed because it has the equal sign, and it's greater than, so it's going to the right. At 7, it's closed, and it's less than, so it's going to the left. So do you see how they overlap here in the middle? Okay, and again, if you were to go back here to the original problem, it is an and problem. So how can I end up writing this answer in interval notation?
-1.
Parenthesis or bracket?
Right.
Good. -1, comma,
7.
and then another bracket. And so that's how they want you to end up writing your answer. Okay, any questions? Also, because you know how I said you could see that this was an and problem at the beginning? You can't actually tell if it's like an and or an or problem until your absolute value is by itself. Okay? So this one right now, it looks like it's an or problem, but we're actually not sure until we get the absolute value by itself. So what would I need to do in order to get the absolute value by itself?
You multiply by the reciprocal,
Which would be
3 over 2, negative 3 over 2.
good, negative 3 over 2. Whatever we do to one side, we do to the other side. And what happens when I multiply or divide by a negative? So am I going to flip the sign?
Yes.
Yes. And so here I can reduce 2 and 6 and I get a 3, and then 3 times this was a negative 3 is a what? Negative 9. Okay, so anytime you end up getting an absolute value where it equals a negative number, the answer will either be a no solution or
A 0
all reals. It could be all solutions, right? And so at this point, this is when I just kind of do the problem where I know that anytime I have an absolute value, when it comes out, it'll be a positive. And is a positive less than a negative?
No.
No. So this one is going to be no solution. Okay, but if it had been, the inequality had been going the other way, it would have been all solutions. Yes?
I don't understand why the sign flipped.
Because I multiplied by a negative.
Okay.
So remember with inequalities, anytime you multiply or divide by a negative number, you end up flipping the inequality sign.
Oh, okay.
Okay? All right, any other questions? Okay, so number 5, I don't like the way it's written right now because the inequality is on the right side instead of the left side. So my suggestion is to rewrite it. Okay, and so we'd have the absolute value of x plus 1 plus 4, and since the open mouth is going to the inequality side, we flip it and keep that open mouth going to the inequality, or I mean to the absolute value, and then I get 7. What would I do next to get the absolute value by itself? Good. And so absolute value of x plus 1 is greater than 3. And so at this point now we can write our two equations. And so we have x plus 1 is greater than 3, and x plus 1 is what? Less than negative 3. Good. Subtract 1 to both sides. We get x is greater than 2. Here I subtract 1 to both sides, and we get x is less than negative 4. Now, at the beginning of this problem, because it's a greater than sign, it's an or problem, which means that's where you have usually the two separate graphs going in opposite directions. If I were to go ahead and graph this, I'd have negative 4 on the left, 2 on the right. At negative 4, it's open, and it's less than, so it's going left. At 2, it's greater than, and it's open, going to the right. Okay? And so how would I end up writing that one in interval notation? Bless you.
Negative 4 and 2.
Because that one is where they're overlapping in the middle. And see how these graphs are not overlapping in the middle? They're like two separate graphs.
So negative infinity.
Yeah. So you'd have negative infinity to negative 4 with the union of 2 to positive infinity. Okay, questions on that? Yes.
Okay, I've never understood the whole union thing. Like how and when do you use it?
You really should use it anytime you're writing multiple interval notations. So anytime you kind of have separates, it's like you're saying that we have this part of the graph and then still part of the graph is this, but they're separate. And so you have the union mark just letting you know that they're all the same on the same graph, but they're just different pieces.
Okay,
Okay?
thank you.
All right, any other questions up to this point? Okay, are you guys ready to try number 6 on your own?
Yeah.
Okay, let's see what you can do. I'll give out a couple candies to the first to get it right, but what I'm looking for to see it written correctly is that you have your interval notation written correctly, okay? And if you need any help at all, raise your hand and I will help you.
And then how do you write that in interval notation?
Okay, so it should have, did you end up getting x as less than or equal to 3? Okay, and one thing that we noticed, so here we add 1 to both sides, okay? We have 3, absolute value of 2x minus 6 is less than or equal to 0. Still trying to do the absolute value by itself, you divide by 3 to both sides. Absolute value of 2x minus 6 is less than or equal to still 0. Can you write two equations on this one? No, because there isn't a negative 0 and a positive 0. So it's always you're writing your two equations once the absolute value is by itself. Okay? So that means we're only going to have one answer. So at this point now I can add 6 to both sides. We have 2x is less than or equal to 6, divide by 2, and x is less than or equal to 3. So if you were going to graph this, you would have 3, and less than or equal to means it would be filled in which direction is it going, left or right? Left, because all the less than values, all the smaller values are left. And so when you're writing that in interval notation, that means it's going to be negative infinity to 3. And since it has the equal to sign, we have our bracket. Okay, questions? We're good? Okay, so next one, number 7, what would I do first? Good, add 8 to both sides. We have absolute value of 3/4 x is less than 12. Okay, absolute value is by itself now, correct? And so we're going to go ahead and make our two equations. So I have 3/4 x is less than 12, and then my other equation would be what?
3/4 x squared minus 12.
Good. And then how do we get rid of the 3/4 in front? Good. Am I going to flip my inequality sign? No, I'm just multiplying by a regular number, right? Okay, so 4/3, these cancel. When you're multiplying by 4/3, I could reduce the 3 with the 12 and make that a 4, and 4 times 4 makes 16. Over here, these cancel, also multiplying by 4/3. Again, 3 goes into 12 4 times, and negative 4 times 4 makes a negative 16. I always think it's kind of easiest to look at these on a graph, but if we were to go back and think about this, once we got the absolute value by itself, is this going to be an overlapping graph or two separate graphs?
Second. Overlapping.
Right, because this is a less than and sign, and is when they're overlapping. So that's kind of how I remember. Oh, it's a less than sign, and so I know less than will end up making overlapping graphs. where if it ends up being a great or, once you have that inequality by itself, then or no, it reminds me, oh yeah, it'll be two separate graphs. And so if you were to look at this graphically, and again, sometimes it's easiest to just go ahead and graph it before you write your interval notation. At negative 16, it's open going to the right, and at positive 16, it says less than, so it's open there going to the left. And you can see that they overlap there in the middle. And so how do I end up writing that answer in interval notation?
-16, comma 16, with parentheses on both of them.
Perfect, that's it. Okay, do I need to explain any of that? We're okay? All right, number 8, what would I do first?
Subtract 4.
Good. Subtract 4 to both sides because we want to get our inequality by itself. We have negative 1/2, absolute value of 4x minus 2 is less than or equal to what? 3. Next step is to do what? Good. Multiply by negative 2 or negative 2 over 1 to both sides. So what, since I'm multiplying by negative, what do I have to remember to do? So it's going to be greater than or equal to, and 3 times negative 2 is? Okay, since I have a negative number, my answer will either be what two answers?
No solution, all reals.
Very good. No solution or all reals. So we kind of make our little, I always write these things down. So the absolute value will always give me a positive, and is a positive greater than or equal to a negative? Yes. Yeah. A positive is greater than or equal to a negative, so that means this one will be all reals.
You don't have to do any more work.
Nope. So it's kind of nice, actually, when you get a negative. Okay, but since it's all reals, how do I write that in interval notation? Very good. So we'd actually end up writing that as negative infinity to positive infinity. Okay. Questions on all that? Okay. Number 9. Every day, a human can eat between 3 to 7% of his or her body weight. Write and solve a compound inequality. So compound inequality is where we have like the two pieces of information. Like, you know, like this. Oops. This is a compound inequality. Okay? So smallest to greatest with your variable in the middle. Okay? Representing the amount of pounds that someone weighing 160 pounds could eat each day. Okay, so this says 3 to 7%. How do you guys think that we would end up writing this compound inequality?
3 is less than or equal to x is less than or equal to 7.
Okay, so you're thinking along the right lines. I'm going to write down what you said, okay? 3 is less than or equal to x is less than or equal to 7. And you're thinking on the right lines, but it's not exactly correct. So first of all, percent. How would we change the 3 and the 7 in order to make it actually a percent? How do you write that? Okay, so we're actually going to have a 0.03, and then we're going to have a 0.07. Now, if somebody said that so if you weighed 160 pounds, okay, how could you figure out what 3% of that is? What would you do? You would end up multiplying it, right? And so if you're writing this as an equation, it ends up that you would actually go x divided by 160 here in the middle. Because, so this is like originally how it is, and then in order to solve it, what would I do to everything? In order to get rid of the 160 on the bottom, what would I need to do? I would end up multiplying by 160, and so each of these end up multiplying by 160. That cancels. And you could get out a calculator, and when you multiply 160 times 0.03, it is 4.8. And 160 times 0.07 is 11.2. And it's always a good idea to kind of play around with the numbers in your equation to make sure it makes sense. Because if you were to divide by 160 to each side, like it ends up making like 5,000 and something. So obviously somebody's not going to eat 5,000 pounds a day. But 4.8 pounds of food, that makes a little bit more sense. even though it still seems like a lot. But okay, so that is your equation, your inequality. Now it says graph the solution set on a number line. So how would I end up graphing that?
You like have a number line. On one side you have 4.8.
Good.
And another side you have 11.2.
And then how would it end up looking?
They would go towards each other.
Good. And so we'd end up having a closed circle. This one's going to the right, this one's going to the left, and it's overlapping in the middle. So it's saying that people could eat anywhere between 4.8 and 11.2 pounds if they weighed 160 pounds. Okay? Any questions?